All right, my data friends, I got a request to show you how to run a regression in Excel. There's a bunch of different ways. On the screen share, you can see some data, X and Y, some other bits and pieces, which I'll show you, and then regression output. This is one of the ways to do it. Let me start from first principles. So I'm gonna make a new sheet. If you want to follow along, go ahead and take any data that you might like. I'll post this up on my site so you can grab these particular ones as well. I got various observations, 1 through 50, and I have some X and Y. Where do those things come from? I made them up. If you go over here to simulated data tab, I have a structure. Let me see if I could. B1, B2, B3, B4, those are parameters. And I introduced some random noise. I simulated some random X variables and then some D variables, which are one hot encoded binaries. For a bunch of the people here, they're zero. For a bunch of the people here, they're one. And then from that, I formed Y. So that's all made up, simulated. I'm keeping this purposely generic, different videos, different use cases. We'll work on that later. Okay, so we want to run a regression on this. So I'm going to put into a clean sheet. I have that over there. One way that you could do that is with line est. I'm going to show you first what you shouldn't do. Go into a cell, put in line est, click on Y, click on X, and then just enter. Uh, 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 uh. Now, okay, so if you take a look at this, then what's the 2.3? What's the minus 7.1? Well, I know when I run a regression, if you follow my cursor down here, I have two parameters, an A0 and an A1. So which one is which? Well, let's go back to what it should be. You go to the simulated data. Alpha 0 is a 1 and alpha 1 is 0.5. But I also have all this other stuff in here. Don't forget the regression is not the truth. The regression is an estimate of that truth. So since we're estimating something, a really simple A0 plus A1, when we know the truth is different, we're not going to be able to recover these exactly. We actually need a more sophisticated model. Take a look at these sheets here and there. All right, so I said don't use this one only because it's not clear from the labeling as to which is which. Maybe we could do something a little bit better. So every self-respecting data analyst in Excel can go to data and data analysis. If you don't have it, here's what you do. Go to File, go down to Options, and then Add-ins and Excel add-ins, and make sure that's checked. While you're at it, Solver, make sure that's checked as well. Okay. So go to data analysis. Whole bunch of stuff pops up. Um, again, data analytics people, you should know what a lot of these are. I'm going to click on regression. And I already ran one because I'm good like that. So what you do is you click the little arrow and you put in your Y's. Click the little arrow, put in your X's. And X is a generic term. I happen to have it labeled here X, but it could be an X1 and an X2. It could be an X and a D. When your regression is written, Y as a function of a bunch of other stuff, the Y is the left, the X, the D, the Z, whatever is on the right. So what Excel is saying is, give me everything that's on the right-hand side, generically call it X. Don't worry about labels, blah, 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 blah. Pick where you want to put this. Boom, right there, easy peasy. You could do some plots, etc. We're not going to do that. Click OK, and you get full regression output. I'm going to zoom out just slightly. Okay, so lots of info there. I'm not going to go through all of it. The video here was just operational. How do you actually implement this inside of Excel? Well, the bottom of the table gives you the coefficients, and there's two outputs, minus 7.6 and 2 point, wait a second, minus 7.6, minus 7.6. I've seen those before, right? And 2.3, wait a second, I've seen that before too. So when you run the line S command, the first coefficient matches the second one in the table. I don't know why they did it that way, but they did it that way. Okay, but what do those coefficients mean? Well, Excel's going to always set this up with your intercept. If you see my cursor down here, A0. That's the first one. So this is like A0. And the second one is whatever is the X variable that you put in here, A1. Now remember what those things mean. That A1 is the slope of a line where it's Y and X space. As you move along that X coordinate, how much more Y do you get? You get precisely 2.3499 more. Sounds like Doc Brown, 1.21 gigawatts. All right. So that's how you run it here. You could either run it with the line est or with the table. Hope that helps.